let's get into interference detection and avoidance. Now, we're going to dive, this is where we're cutting into the layers, we're getting a little bit deeper into the technology. So one of the things that you need to clearly understand, and I think everybody clearly understands, Wi-Fi interference comes from wireless or Wi-Fi sources. You know, we mentioned it before, you know, microwave ovens, cordless phones, kids' toys, especially in 2.4. But there are some non-Wi-Fi based interferences that can come in. And you know, you may be sitting there going, well, you know, what are you talking about? You know, if you're not familiar with like electromagnetic, harmonic type frequencies based on motors, generators, things of that nature, this can happen. And this happens quite a bit when you get around sources of mechanical, like warehouses, manufacturing, electric generators and power generators, like for the utilities. We always get the question of, well, you know, I'm running this near a high wire, you know, high power lines and stuff like that. That's 60 hertz. That doesn't bother me. Is it close to the generation center? That bothers me. Because they're running at a lot higher frequency to push all that power out through those lines.
By close you mean 500 feet? 5
Oh.
miles?
Well, see, okay, so this is where, and this is an example of it, but this is where getting a true spectrum analyzer so that you get a, and it's not that NetStumbler and all those devices like that show you the Wi-Fi. But getting a true spectrum analyzer gets you into the level where now you can look at all. There's got to be a way to capture all the sources. Everything, here's the deal. Everything that you see, hear, has a frequency. My voice has a frequency. Your monitor has a frequency. The power supply in your device has a frequency. Everything has a frequency. And so, you know, some of it, non-interference, not a big deal. The lights have some bearing on frequency depending. I mean, there's all sorts of things. What was it? I saw this one the other day when I was digging through and looking at sources of interferences. Plasma cutter. A welding type device, a plasma cutter, has a source of interference that directly 100% interferes with 2.4. So if you're dealing like again, let's go back to the manufacturing and welding shops and things like that that they want to use for RFID tagging, they wonder why it fails. You got a plasma cutter in the shop? More than likely, yes, that's your failure. And so the reason why that this is so important to clearly understand is that you got to have a way to deal with it. Now, some companies out there, the way they deal with it is they just alert. They alarm and alert and let you know through their management or monitoring system that, hey, there's interference. You know, but you got to deal with it. You've got to go out and figure out either, do I switch channels? Do I look for something else? Can I, you know, what do I do? And so the issue is that sometimes if you're not having a 24/7 monitoring knock or, you know, a source where people can, you know, watch this thing 100%, the issue can come and then it can go and it's totally inconsistent. This is why site surveys are great, but I never say they're 100%. They're 95, 99% maybe, because when you do your site survey is only for that portion of time and date. And it really and truly, it's one of those situations where that source of interference can pop up at a totally different time that after you deploy, the customer's like, dude, we lost our video for like 6 hours in the middle of the night from 1 to 5 a.m., 1 to 6 a.m. What the hell? You know, and it's like, well, what are you talking about? And now you got to go out and figure out what's going on. You know, it's situational. This is why I say environment, it's so subjective for wireless. We had a situation, I'll tell you this, in Cupertino. For 1 hour, one link in the network went down. And it was due to way too much interference, way too much, to the point where we couldn't find another clear channel. We had no clue. We still don't know to this day, but all we did was we switched that completely out of that spectrum into 2.4 and got it out of 5 gigahertz, and it's been fine ever since. But I mean, it's one of those things that, again, even in your post-deployment, you may have to go out and try to start figuring this out. Now, that being said, there are things and, you know, methods of dealing with interference, and I mentioned it a while ago that a lot of competitors, go out there and they find it, alert you, and you got to figure it out. But it's truly coming into the avoidance perspective. How do you deal with this? So, from Azalea's perspective, you know, of course, we first of all detect the Wi-Fi data as well as the non-Wi-Fi based noise. And so, we make a determination, and you'll see this even in terms of like our radio frequency, technology when we do debugs and show commands and things of that nature. We'll get into the troubleshooting aspects in the labs, that you can see where some sources, so there's physical noise and there's RF noise. There are certain things, just because you're in this environment, that due to the environment, you're creating either self-interference noise, or there's other noise aspects where the signal's bouncing off the walls. We've seen situations where just the way an antenna was set up or configured, it was literally bouncing off the walls to where it was canceling and nothing could get connected to it. There's just all sorts of things. It's the best thing I can describe it as, it's go back to your physics 101 of what you learned with lights and reflections, and it's the same aspect. Whatever you do with light beams, it's the exact same aspect with wireless. And it's really interesting because a lot of people don't ever see this aspect. They just think that wireless just permeates. Hey, I'm in my class. I got, I flip open my phone. I got bars.
That's deceiving.
Yeah, it's real deceiving. Exactly, it's very deceiving. And so they think, well, if I can do this with a phone, how much more can I do it with a wireless, and wireless networking, And so it becomes deceiving. Now, the detection that happens with Azalea is that we determine, is it something that's us or outside of us? So some of it is, like I said, self-interference, meaning that one of the other radios, especially when you get into multi-radio situations, sometimes you can accidentally angle your antennas in a way that they start interfering with one another, even within the box or even externally from the box. And so, what do we do with those kind of situations? Other aspects is, again, source. Somebody gets flipped on a wireless signal for X amount of time, and we detected noise. Regardless, the system's going to detect it, and so the Wi-Fi detects the Wi-Fi data for a period and calculates a percentage of how much time is used by that. So the idea is that what it's trying to determine is there enough interference that I've got to do something about it? So what do I mean when I say that it calculates it for a period and determines how much time? So, you remember a while ago I mentioned that Wi-Fi and 802.11 is half duplex in nature. And it's based upon one of three things. I'm listening, I'm talking, or I'm waiting. It's time. It's synced. It's the idea of, it's the informalness of CV radio. You wait for the channel to clear for you to key your mic and talk. It's the same kind of aspect that if I don't have an awareness, if I don't have a visual, if I don't have anything that relates me to where you are, how do I know when to talk? In wireless terms, okay? So the same thing is happening is that in terms of time, what Wi-Fi and 802.11 standards have done is said, well, we've got this, in essence, back-off timer and contentions and all these time slots that you talk at this time, he talks at this time, he talks at this time, he talks at this time. And so what happens is that, all right, I start off, I'm talking. I can only have the medium, this air, for X amount of time, and then I release it. When I release it, it's whoever's next in line. Now, I'm in waiting mode. Now, what I'm waiting for is one of two things, my turn to talk or somebody talking to me. And so if Anil is a router, hey, sorry, I'm not degrading you to a router, but if he's a router, it's his turn to talk, and it's the discussion of, well, is it your turn to transmit to me, to somebody else in the group, or are you waiting to receive something? And so it goes around. Now, this is why, in an area where you got a high concentration of a number of devices, it may have the seemingness of, well, you got a lot of latency. No, you have a lot of contention, meaning contending for the bandwidth. Contending, what is the bandwidth? It's the space. You don't have a physical medium that dedicates me to connect to him and talk to him exclusively. So the time period that we're talking about here is detecting when all this chatter and this interference is going on, is it enough that I'm wasting a lot of time waiting for my turn to transmit what's most important or to receive what's most important? So, like I said, again, it can be my own Wi-Fi noise, other Wi-Fi noise outside of me, or even other non-Wi-Fi source. So if we're not dealing with a contention of just Wi-Fi 802.11 devices, now you got a 100% pure interrupted device that has he's not following the rules of the game for 802.11 talking. Think about this. You get a source like a generator or a plasma cutter or anything, it doesn't care about 802.11 standards that says, wait your turn until you can talk, and it doesn't do any of that. It sits there and actually will cause more noise. And so what it's looking for is, does that thing consume 100% of the time? Or is it consuming the right amount of time? Is there too many devices that are consuming too much time in my channel? So when